Electric motor starters are essential for motor control and overcurrent protection. This video series provides the electrical characteristics and the operation of electrical starters. The first video identifies relays, contactors, and starters. The second video explains motor current and the basics of overload protection of motor circuits. The third video identifies starters and the purpose and characteristics of motor overcurrent protection. The fourth video identifies the purpose and characteristics of the auxiliary contacts of a typical starter. The basic operation of a relay, a contactor, and a starter are the same in that a magnetic coil controls the operation of one or more sets of normally open or normally closed contacts. A starter includes an additional component that monitors the motor current. The current overload sensor is designed to interrupt the coil voltage if an overcurrent occurs. A starter is designed to send the motor the correct operating voltage. The coil of the starter is designed to operate at a specific voltage. The operating coil of the voltage may, or may not be the same as the operating voltage of the motor. In the example shown, the starter is supplied with 230 volts. Note that in this example, the coil is rated at 230 volts. Any two of the three main power lines can be used to supply the coil. Line 2 supplies the coil with power through the normally close contacts of the overload sensor. Line 1 is used to supply the other side of the coil by means of control devices such as push buttons. The ladder diagram shown is a typical stop-start control circuit. Line 1 supplies the control devices. The stop push button is normally closed while the start push button is normally open. The push buttons are placed in series. The start push button is used to energize the coil. The stop push button is used to de-energize the coil. Typical stop-start control use a red, normally closed push button for stop, and a green, normally open push button for start. The red, normally closed push button, the green, normally open push button, and one side of the coil are connected in series. To keep the coil energized after the start push button is released, a normally open contact, controlled by the coil, is placed in parallel with the start push button. This contact is referred to as a holding contact. The stop push button is used to interrupt the power and de-energize the circuit. The holding contact used in the coil circuit is a normally open set of contacts controlled by the starter coil. Since the main contacts control the voltage to the motor, the contacts used in the control circuit are called the auxiliary contacts. Auxiliary contacts are an additional set of contacts that are operated by the coil. A typical starter is supplied with a set of normally open contacts that are controlled by the coil. Auxiliary contacts are typically rated for less current than the main contacts. Auxiliary contacts are used in the control circuit. These contacts are usually located on the left side of the starter and may be identified with the letters N, O. The ladder diagram shown here demonstrate how the auxiliary contacts are used. The auxiliary contacts are used in the control circuit to keep the coil energized after the normally open push button is pushed. Starters may be supplied with additional auxiliary contacts. These additional contacts may be normally open or normally closed. Remember, all of the starter contacts, both the main ones and the auxiliary ones, are operated by the coil. The field wiring of starter control circuits require the ability to interpret ladder diagrams and install the correct wiring from the ladder diagram. Let's examine a stop-start ladder diagram and its corresponding wiring connections. This example illustrates the corresponding connections between the ladder diagram components and the actual control components of the starter. Line 2 is typically routed through the normally closed overload contact to complete the control circuit. Please note that the connection wire between the coil and the overload contacts may be installed by the manufacturer. In this example, 460 volts is supplied to the starter. Both the motor and the starter coil voltage are rated at 460 volts. The supply voltage is used to supply the coil with the necessary operating voltage. Even though the control circuit will operate the starter, the close proximity to high voltage is usually undesirable and unacceptable. The location of the push buttons may require that a lower and safer voltage be used. A control transformer changes a high voltage into a low voltage. A control transformer uses the primary incoming voltage and transforms it into a lower and safer voltage. The lower voltage is then used to control the starter coil. The operating voltage of the starter coil must match the voltage produced by the transformer. The lower control voltage provides a safer electrical environment for the operator. A control transformer creates a lower and safer voltage for the starter control circuit. The lower voltage produced by the transformer, called the secondary voltage, is identified on the transformer as X1 and X2. This voltage is used to control the coil. In this example, the operating voltage of the coil is the same as the lower voltage of the transformer. The X2 connection is supplied to one side of the coil through the overload contacts. A motor overcurrent will open the normally closed contacts and prevent power to the coil. The X1 connection is used to supply power to the coil through control devices. A control transformer produces a safer electrical environment. A starter is used for the control and protection of a motor. A starter consists of two components. The top part of the starter consists of the main contacts that supply power to the motor and the auxiliary contacts that are used in the control circuit. Both the main contacts and the auxiliary contacts are controlled by the starter coil. The bottom half of the starter is the current overload sensor. It is designed to monitor the motor current and interrupt power to the coil if an overload condition occurs. It does this by opening a normally closed contact that is controlled by the overcurrent sensor. A motor starter is an electrical device that provides for the control and protection of a motor. Starters are a crucial part of the electrical and automation industry.